In the last video, we have seen an introduction to printed circuit board. Now, why this printed circuit board comes into the picture? What might be the advantages of PCB designers? The first point is the size of the component assembly is reduced. The term assembly means once you get integrated with all the components of your design, after integration the finalized design that is being made in the PCB represents assembly. So the size of the component assembly is reduced, meaning is we are reducing the size. That is, if in the previous video I shown an example related with a processor design, that is with the help of a motherboard that is seen. Now in this case, if I am going for some advancement or recent technology, the main objective of the PCB should be concentrated on reducing the component assembly, that is reducing the size. Second point is quantitative productions can be achieved. The term quantitative production means as the years increases, the device advancement should be in such a way that more features should be achieved or should be enhanced while distributing a product. The quantity here represents, say for example, initially we were using a mobile phone where we can't even visualize a mail that is being received from us. But nowadays, apart from these features, there are more enhanced features that is being available in the mobile. This is made with the help of this quantitative productions. So make a remember that whenever you are constructing a PCB, your quantity should be very high as much as possible. Second, on the third point is component wiring and assembly can be mechanized. What do you mean by the term mechanized is, let me recall the previous example that were dealt in the previous video. In this case, if you look into the design of a motherboard, the components are placed, some components are placed nearer together and some components are being placed away from to each component. Whether we are going to place all these components manually? No, we are not going to place it. If we are not going to be placed manually, then it should be mechanized. Why it should be mechanized is placing of the components time can be minimized to a greater extent. So whenever we are designing a PCB design, make a remember that if you are going to integrate all the component, it should not be made manually, it should be mechanized. Meaning is, once you construct a PCB design, you have to move into the machine. That machine should be capable of placing all the components in the design that you prescribe. So it should be in such a way that all should be mechanized. So that will be the third advantage of the PCB design. Next, circuit characteristics can be maintained. What do you mean by circuit characteristics? See, in electronic circuits, we know that a circuit will mainly gets affected due to a parameter that is named as a noise. So whenever you are concentrating a design of a PCB, make a remember that the noise component should be minimized as much as possible. Not only that, if I am going for a design of a large signal amplifier, say for an example, if I want to design a large signal amplifier, make a remember that the parasitic capacitance should be minimized as much as possible so that the circuit characteristics can be maintained. The meaning of circuit characteristics represents a term as even if there is a temperature variations, the circuit should function as the same. Next point is it should ensure high level of repeatability. What do you mean by the term repeatability? See, we are going to do a process. That process is named as repeatability. Now, why repeatability is essential in PCB design or where it is going to be widely used? Repeatability. The term repeatability here represents testing process. Whenever you are constructing a PCB design, after final integration is over, we can't release that PCB to the market simply as such. We need to check its functionality, we need to check that particular PCB under different conditions, we need to do several tests, only then we can release the PCB to the market. If I want to do such a case, I need to go for a process named as repeatability. The term repeatability means I am going to test the circuit frequently using several parameters like working under different conditions, or I am going to test whether that particular portion of a circuit functions properly or not. So this is done with the process of repeatability. Only then what can be achieved is we can obtain a PCB of a error free, which means that PCB will be used for a longer amount of time. Sixth point is location of ports is fixed. The meaning is, let me take the previous example that is discussed with the motherboard. You can visualize a pen drive that is being inserted under a USB slot. If I consider this USB slot to be available at the center portion, say for example in place of a heatsink, I am going to have an USB slot in this place. Whether this is going to be useful for interfacing a PCB? Definitely not. I can't bring this pen drive to this point to interface in it. So I need a proper location of the devices that should be available when I am constructing a circuit. This is for an example. So whenever I am going to connect a USB port, then which means that I need to connect the USB port only at an outer portion of this PCB, which means I can interface an external component with a component that is being available in the PCB. So this is what the meaning of seventh point, the location of ports is fixed. Whenever you are designing a PCB, in initial case itself, you finalize where the ports should be placed and how the port should be placed, whether the port should be placed internally or whether the port should be placed externally. You have to make a remember of it. Next is inspection time is reduced. How inspection time is reduced is by the property of repeatability. Once we are frequently testing this PCB using several parameters, we will be in a confident level that this PCB is going to be work under a good conditions. If it is a case, then incoming inspection testing can be reduced as much as possible. Last point is short circuited wiring or minimized. Meaning is, if I look into this motherboard, you can clearly see that there is some spacing that is being provided between this routing path and this routing path, which means there is no way connection between this particular wire and this particular wire that is being available. So whenever I am going for a connection, this is going to connect and it is going to take a path like this, and this is going to take a path like this, which means there is a proper isolation that is being provided between each and every layer of a circuit. You could see three different lines that is being marked in a thick portion. This thick portions represents isolation. Whenever I am providing an isolation, the major advantage is I am going to prevent a short circuited wiring. Whenever short circuited wirings are being minimized, effective achievements of circuit can be obtained, which means the circuit is going to work very good. This is the meaning of the short circuited wiring or minimized. These are some of the advantages of a PCB design. This is why PCB designs are mainly used nowadays for constructing any kind of a circuit that is being available in the market. Whether it is a mobile or whether it is a lab or whether it is personal computers that you are using, all will be manufactured, and this PCB is going to play a major component in it. The next upcoming video, we are going to see what are the components that is involved in a PCB, what will be the classification of a PCB, if I am going for a classification of a PCB, which PCB can be used for which particular application. So this is what the next video concentrates on.